All right, so we're talking about the actual curves themselves now, the polar graphs themselves, all right? So the polar graph, and the graphs of the polar system, there are actually three types. There are actually two big types, the rose petals and the limacon, and then there are the rest, okay? So we've actually seen the rose petals, and we've seen the limacon, okay? We haven't talked about the others yet. So in the rose petals, in the rose petal graphs, the graphs look like, they're in this form, sine and theta, or cosine and theta, okay? And so we looked at 4 cosine 3 theta? Back in example 1, we did 4 sine 3 theta. Okay, and then on example number 3, we did cosine 2 theta. Okay, so when it said sine 3 theta, there were 3 rose petals. But if you did the 2 theta, there were 4. If you do the 5, you'll find out that there are 5 rose petals. And when you do the 4, you'll find that there are 8. In other words, if your n value here is an odd number, and it's like a 3 or a 5 or whatever, you'll get that same amount of petals, rose petals. So if you have 3 theta, you're going to get 3 rose petals. If it's 7, you'll get 7 rose petals. Now when n is not odd, but it's when it's even, if it's 2 theta, you get 4. If it's 4 theta, you get 8. If it's 8 theta, you get 16. So if it's an even number, you get twice the amount of the 2n number of rose petals. Okay? So if you look at that, that's on page 497, the blue box there. Graphs of r is equal to a cosine n theta and a sine n theta, where the number of symmetry, okay, they are all symmetrical across the y-axis, the x-axis, and the origin. Okay, so when it's odd, it's symmetric. A sine theta, as we saw, was symmetric across the y-axis. The cosine theta would be across the x-axis. Okay, and then if it's even, when n is equal to when it's an even number, it's symmetric across everything, x, y, and the origin. Okay. So that's all we need to talk about there. So let's look at the limacon curves. The limacon curves, okay, these were the rose curves. So on the limacon curves, look like, the equation looked like r is equal to a plus or minus b sine n theta. Okay, and this is what it looks like, or b sine theta, sine theta, or a plus or minus b cosine theta. The sine theta and the cosine theta really determine the orientation of it. The limacon actually is a French word that means snail. So if you do 3 minus 3 sine theta, okay? If you do 3 minus 3 sine theta, you'll get something that's, so sine theta, the orientation looks like this. So this would be for sine theta. For cosine theta, it's going to look like this. So your cosine theta, the graph's going to look like this. And as far as this dimple goes, some of them are dimpled like that, and some of them have a little tail in them, and that's shown on page 498, the very top. If you look at the very top, depending on the value of a divided by b here, the ratio of a over b dictates whether or not it's going to look like this, whether it's going to have a tail, or whether it's not going to have any dimples at all. Okay, and that is on the top of page 498, and you can look at those and view those and see what they look like. Okay, all right. And then as far as the other ones, there are some funky looking ones on page 499. On page 499, if you look at the others, you have, looking at example number 7, you could have r is equal to theta. R is equal to theta. All right, if you could go r is equal to theta, and you graph that, you're going to get A. You're going to get the very top one on the left-hand side. Okay, the spiral there, Archimedes spiral is what it's called. All right. And then on example number 8, you get the lemniscate curve, okay? And that's when you do r squared is equal to 4 cosine 2 theta. R squared is equal to 4 cosine 2 theta. And if you graph that, you're going to get the lemniscate curve, okay? So as you can tell, okay, this section, the actual graphs themselves is not really all that interesting. There's some interesting things, but it's not, in the grand scheme of things, it's not all that important. Okay? All right, so we'll call it a day today.